So overall reaction, carboxylic acid and an amine, I've chosen a primary amine for this example, to producing the amide and a water molecule. We're going to use the amine as a nucleophile. It's neutral. It's a relatively weak nucleophile. We're going to need to activate our electrophilic center. We have the nucleophile here attacking the electrophilic center. And down here, the lower part of the slide, we've got the loss of the water molecule, which you need in order to complete the amide. Activation of the electrophile, nucleophilic attack, rearrange the position of the protons by deprotonating from nitrogen, protonating the group which is to come out, heteroatom or lone pair assisting in the breaking of that carbon-oxygen bond to liberate H2O, the water molecule, as a neutral structure, and finally, loss of a proton to complete the amide. Just look carefully at this last step. There's our driving force, and when that pair of electrons, which is a lone pair on the nitrogen atom at the bottom structure there, when that pair of electrons comes in to assist the breaking of the carbon-oxygen bond, it is forming a second bonding overlap temporarily, because it's not there to the same extent in the amide. And you can see that written here in a double bond from the carbon to the nitrogen. And that nitrogen atom is carrying a positive charge in that structure. And then the loss of a proton here, the way I've drawn it, in terms of going from the top structure here down to the very bottom one on the slide, loss of a proton to form the carbon-oxygen double bond and redrawing the electron density onto the nitrogen, that gets you to the picture of the amide that you'll all find in the textbooks, the resonance form of the amide. But in fact, there is a considerable spread of charge across this amide.